हाय, गुड इवनिंग।
Good evening.
आज बस हम दोनों ही हैं।
Sorry?
आज बस हम दोनों ही हैं, शर्वरी और सुषमा।
Sushma is in school, school it seems, and Sharveri said she is outside, so she might or might not join.
अच्छा, ओके।
Okay, so we'll just finish this. It's a small chapter. With this, we'll be done with our introduction into engines. So
ओके।
the first thing that we are going to talk about for today is your compression ratio. Now, what compression ratio is? It is the amount of the total volume your piston can hold, that is your cylinder can hold, to the volume when your piston is moving up towards the TDC. So before going into what compression ratio is and all those things, we have to talk about few terms. So we're going to talk about total volume, your swept volume, and then your clearance volume. So I'll explain what is all the first three things. So total volume is, you know what is TDC and what is BDC. So the top part of your piston is your top dead center. Let's say this is your top dead center. Uh, okay, sorry. So this is your top dead center, and then this is going to be your bottom dead center, which is your BDC. Now, your swept volume is the distance from your top dead center to your bottom dead center is called as your sweep volume, where your piston is sweeping down. Whatever volume it can hold is called as your sweep volume. Then when your piston is on the top, from your top dead center to all the way till the top of your cylinder is called as your clearance volume. And then adding these two is your total volume. So this is all the three volumes. So you have your swept volume, you have your clearance volume. Adding clearance plus swept gives you your total volume. So this is your three types of volume that we have to know. Now, when we talk about your piston ka like compression ratio. So compression ratio is the ratio between your total volume to your clearance volume. So when your piston is moving down, it is going to get in fuel. A lot of fuel is going to be there. And in your compression stroke, your fuel is going to be compressed within the area of whatever clearance volume you have. So we can get the formula that compression ratio is equal to total volume by clearance volume. Now this is the formula, that is how much amount of your fluid can be held in your cylinder to what is the clearance volume that your fluid is having, and that is going to give us our compression ratio. So why is your compression ratio very important is the greater the compression, the more the efficiency our fuel is going to give us. It increases our thermal efficiency. That means our mean effective pressure is going to be higher. So this is going to result in a higher load on your engine parts due to high working pressure. So that is why when talking about your engines, your piston and your petrol engines like gasoline or any petrol engine is going to be of a low compression engine, because what happens is your gasoline, especially when you compress it to a very high pressure, it automatically ignites because it cannot withstand that much amount of pressure because its flash point is a little low when compared to your diesel. So diesels are called as high compression ratio engines because they can withstand high compression ratios to very greater extent, and since they are withstanding that much amount of pressure, diesel engines are going to be heavier built because they have to withstand that much amount of pressure. So that is one of the reason why we don't use diesel engines in our aircraft, because of the increase in heaviness of your aircraft car engines. So this is gonna be a problem because by knowing what is your compression ratio, until what extent you can compress it, you have to choose the correct amount of fuel. Though what fuel can you choose? What grade of fuel can you use? So that you don't have knocking. Knocking is your pre-ignition. When your compression is happening, we know that our pressure and our temperature is going to increase. If I compress it to a very greater extent, it will increase all the way to a peak value where even before us giving a spark, it is just going to start combusting, which is going to be a problem for us. So we have to choose a fuel to that particular engine where you're going to have the right amount of your compression ratio. At the same time, for whatever compression ratio we get the best thermal efficiency, and it all happens in a sequence. Whenever we have the combustion, it should be when we give a spark. Other than that, we should not have combustion because it is gonna decrease the efficiency of your engine. So this is your compression ratio, where we are gonna take the ratio between your total volume to your clearance volume. So you have a problem, little bit of a problem. That is, whenever we measure your cylinder capacity, we always say it in cubic centimeters or cubic inches. Our aircrafts were measured in cubic inches. Like cars, two-wheelers, bikes, and all those things will measure it in cubic centimeters. That is your cc. So if your swept volume, that is the distance from your TDC to your BDC, top dead center to your bottom center, was 1300 cc, and your clearance volume is 200 cc. So your total volume is going to be 1300 plus 200, which gives you 1500 cc. Now talking about a compression ratio, the ratio between total volume to your clearance volume, that is 1500 cc divided by 200 gives you a ratio of 7.5 is to 1. That is, we have made a unit, like we have put 7.5 units of fuel, which has been made into 1 unit of fuel in your clearance area. So this is your compression ratio, that is 7.5 is to 1. So if let's say we put 7.5 objects in it, we compressed it so much that it is now in the size of just one object. So it is no more 7.5 objects. In this case, you're going to have high pressure as well as high temperature, but sufficiently high enough that it doesn't detonate on its own. When we provide a spark only, it starts igniting. So this is how we increase the thermal efficiency of your engines. Do you want to note it down, or can I go to the next slide?
You will share the
I'll share
PPT.
this. I'll share it after this class ends.
ठीक है.
So next thing is we are going to talk about is the components of your engine. So first one that we'll talk about is your crankcase. So crankcase is the place which is going to hold your crankshaft. So this lower part which is highlighted in red color is your crankcase. This is what is going to hold your crankshaft. So in this crankshaft is then going to be connected to your piston and all those things that will go into detail later. This crankcase is gonna have vents to breathe, because your oil, like you're gonna have oil if it's a wet sump system, or you'll have all the other components if it's a dry sump system. So inside this, you'll sometimes have oil in it, which is gonna be poured into your cylinders to cool down. Our Cessnas, we were using these type of wet sump system, which is gonna act like a bucket in a like JCB. So whenever your piston comes down and moves up, it is gonna splash oil into the cylinder places, where you're gonna have cooling effect and lubricating also provided by your oil. Now, these things will have a vent in it. Why do we need a vent? Is because whenever this whole thing is like going up and down, when it's moving, it is going to be hot. Since the whole thing is since the whole thing is moving up and down, there is going to be some more amount of pressure being generated, because we have an increase in temperature also. So to reduce that pressure, we need vents, and to cool your oil down also, we need vents. So these are the things that we have a vent in your crankcase. So this vent is made in such a way that we don't have a leak of oil. It only allows the air to be vented out into the atmosphere and not your oil. So the whole crankcase is going to be made up of light alloy, and it is going to be made in two halves. It's not just going to be one single whole case that is going to be connected. It will always be made up of two halves that are going to be connected using nuts and bolts, so that if you want to remove it, you can remove it easily. Instead of having one whole thing, you can just remove one part of your crankcase. So this is the crankcase, is the first component of your engine. Second one is you have your crankshaft. So crankshaft is a mechanism that is going to convert your piston ka vertical movement. So your piston is going to be moving up and down in the vertical direction into a rotary motion. Now, when your piston moves up and down, we have a propeller spinning in vertical rotary direction, right? Like even for cars, our piston is going to be moving up and down only, but our car ka wheels rotate in the horizontal plane. So to give that rotation, we are going to use this crankshaft. Crankshaft is one of the main like component of your engine. Now, how this is going to be working is your crankshaft is going to be connected. So your propeller is going to be connected here in these points, where with the like bolts and nuts, where you have to have all the bolts that are bolted together and nothing should be loose. This we check during our pre-flight. And every gap that you see here, here and all, we are going to connect your your piston car rods. That is the next thing that we are going to see. So your piston car rods is going to be connected to these things, and when they move up and down, these things are going to start rotating. So you'll have bearings in it, which is going to help us in having that circular rotary motion without any loss of your horsepower. But due to the friction of your bearings, if it's not well lubricated and all these things, we are going to have a loss of power that is called as your frictional horsepower, which is going to be lost. So you can have only some amount of power that is being given by your engine. So we have to subtract from your indicated horsepower to get your brake horsepower. Now we are going to talk about how much we have a term that is called as your crank throw. So crank throw is how much distance this crankshaft from the lower portion of your crank to the upper portion it moves. That is going to determine how much your piston moves up and down. So each one way up is a crank throw, your piston is going to move one way up. So if your crank rotates 180 degree, it is going to move down. That is what is going to determine how much your piston can move up and down. So this is all one of the major components of your crankshaft. And your crankshaft will be always kept in your different firing orders. So we have something called as firing orders. That is, let's say we have a 4-cylinder engine. Each cylinder should produce one power stroke at different times. Never ever all the 4 cylinders or any two of the 4 cylinders will produce the power stroke at the same time, because this is going to cause a lot of misorder. That is, it is going to create a lot of vibration in it. To balance out the vibration, when your first engine is on the power stroke, your second engine will be in the compression stroke, or your third engine will be in the intake stroke, your fourth engine will be in the fourth cylinder will be in the exhaust stroke. So we have different firing orders. So in a Lycoming engine, your firing order is going to be first cylinder will have a power stroke, then comes your third cylinder. So first odd cylinders will have the power stroke, then comes your even cylinder. So 1, 3, 2 and 4. This is always the order. Mostly this will be the order in different manufacturers. It will be either 1, 3, 2 and 4, or if you have 6 cylinders, it will be 1, 3, 5, 2, 4, 6. Why do we have not have 1, 2, 3 and 4 is, if you have 1, 2, 3 and 4, then also you will have a lot of vibrations. To balance out these vibrations, it will always be in this order. So if you see this 1, 3, 2 and 4 order, that is, if when your first cylinder is in the power stroke, your third cylinder is going to be in the compression stroke. So you can see here, let's say this is where your first cylinder is connected. So it is in the power stroke coming down. Now this is the compression. This is, let's consider to be your third cylinder, where it starts moving up. When it comes down, it moves up into your compression stroke. And your second cylinder will be in the either in the exhaust stroke or maybe in the intake stroke. And your fourth cylinder will be in a way different stroke. So all the 4 cylinders are going to be in 4 different strokes, so that you get equal amount of power in every single stroke of your crankshaft. So this helps us in getting power stroke, at least one power stroke out of that 4 cylinders in all the 4 strokes. So this is how you're going to have it. Now, your 4 cylinder engine is your crankshaft is gonna rotate 4 times. That is, sorry, your crankshaft is gonna rotate 720 degrees. That is, each stroke is gonna account for 180 degrees of your crankshaft car rotation. So if you have depending upon the number of cylinders, so in total you have 720 degrees. So divide that by number of cylinders. If you have a 4 cylinder engine, for every 180 degree, you have a power stroke. If it's a 6 cylinder engine, divide 720 by 6 cylinders, you're going to have power stroke for 120 degrees. If it's a 8 cylinder or a 10 cylinder, you're going to have lesser than that. So if it's a 10 cylinder engine, you're going to have power stroke for every 72 degrees. So depending upon the cylinders, the crank angle is going to change. So that is why we mostly have, like if it's a rotary engine and all, we have odd number of cylinders because of this particular reason. If you have even number of cylinders, sometimes two cylinders will be at the same power stroke, which is not going to balance out, which is going to produce a lot of torsional momentum on your crankshaft, and your crankshaft can break. So if a crankshaft bends or something happens, your engine is going to cease, because one or the other piston is going to misfire. That is, it won't be in the whole top dead center. It will be on the way towards the top dead center, but your spark plug would have given a spark thinking that your piston is already at the top dead center. This is gonna misfire it. That is, your crankshaft can rotate in the opposite direction, which should not happen. If it happens, your crankshaft can even break. So that is the job of your crankshaft. That is, it is the main place where you're gonna convert your vertical motion of your piston into a rotary motion to spin your propellers. Next is about your connecting rods. So these are your connecting rods. So you can see here, this is your piston head and the whole thing is your piston head, and under this is called as your connecting rod. The job of your connecting rod is to connect your piston head. So whatever you see here, the topmost part is your piston ka head. That is, this whole gray part that you have is your piston ka head, and inside it you're going to have this one. So the small end goes here into the piston ka head, and the big one is getting connected to your crankshaft. So you're going to have a bearing that is going to be fitted here, and it is going to start rotating. Now this is the one that helps us in converting. This is also the one that helps us in converting your vertical motion of your piston into your like rotary motion of your crankshaft. Now, how are we going to connect it is we have something called as a gudgeon pit. So you have to remember this name, gudgeon. The gudgeon pit is, I can't show this in 3D, but you can see this hole here, right? This hole is going to have a pin inside it. So that pin will be going through this piston, and you're going to have your piston ka head on the top. So this is how your gudgeon pit is going to be. And inside this, you can see this particular pin. This is called as your gudgeon pin. So you have your gudgeon pin and the whole area inside it, inside the piston. If you see underneath your piston, it's called as your gudgeon pit. So this is going to be connected, and you can convert your head, you can convert your vertical motion of your piston into a horizontal motion of your, sorry, rotary motion of your crankshaft. Now the topmost part, that is this shaded part of your piston, is called as the piston crown. Now your piston crown is the one that is going to take the maximum force of the combustion, because your spark plug is going to be here, and it is gonna, this part is going to be exposed to all the combustions always. So in case if it misfires, in case if it detonates your fuel or something happens, which is not supposed to happen, which is not a normal operation of your engine, this whole top part can break. If it starts to break, then in that case, you're not going to have effective combustion, or you're going to have leaking of your fuel into the oil pot. Because in this place, let's imagine you have your crankcase. It is, your crankcase is going to be like this. And when your crankcase is in this way, your oil will start seeping through this piston crown, and it will leak through your connecting rods into your crankcase where you have oil in it. Let's say if it is a wet sump system. So when you have oil mixing with the fuel, there are chances that this whole thing can burn and your engine will cease. So we should always be aware that there are chances that these things can happen and you can have engine failures. The other part of your engine that we have to talk about is your piston rings. So piston rings is on the side, you can see these three silver colors, right? It's basically a rubber seal that is going to be kept, and this seal is kept because to not let your fuel from the top seep into your oil system, or not let oil to seep into your fuel. In both the cases, you're going to have ill effects. That is, if your oil leaks into your like combustion chamber, in that case, you're going to have black smoke coming out of your engine, because your oil also starts to burn, which should not be allowed. You'll either have a white smoke or a black smoke coming out of your engine, depending upon is it dirt and oil burning together or just oil burning. So if it's just oil, you'll have white smoke. If it's dirt that is also burning together, you are going to have black smoke coming out of your engine, which means that you have a broken piston rings. Your piston rings has to be changed. So to change your piston rings, you have to remove the whole upper wala piston engine assembly, and then you have to take out the piston head and you have to seal it, change it. So this piston rings are called as O-rings. That is your just O and rings. So this are going to be made up of rubber, and they act like more like a wiper. So how in a car we have a wiper that is going to like while away what like wash away water. The same thing your O-rings are also going to do. So you have a lower O-ring, you'll have an upper one. When you go up, it is going to like remove all the fuel that is there inside your piston car and on the side of your cylinders. And when it comes down, it is going to remove all the oil there is on the side of the cylinder. So not oil, neither fuel mixes with each other, and you have a very good working engine. If in case you have something else, it is not going to help us in like getting an effective combustion. So these are your piston car rings. So you have compression rings, which prevents, the top part is your compression ring, which prevents your gas leaking into your case. And you have a scraper. Scraper is basically like a wiper, which is going to prevent oil from entering into the combustion chamber. So these are your components of the piston car heads. Next thing is you have your cylinder barrel or called as cylinder blocks. So cylinder block or cylinder barrel is the side of your cylinder where you can see this brown like shaped like which is shaped like zigzag wala shape. This is called as a cylinder barrel. Now what is the job of your cylinder ka barrel is to give us more amount of area to cool your engines. So whenever we use a air cooled engine or a liquid cooled engine, we'll talk about first air cooled engines. In case we use an air-cooled engine, the whole side of your barrel, let's say this is your cylinder, and on the whole side you will have something like this, like they will be having few metal pieces popping out of your engines. So these metal pieces are called as fins. Now what is the job of the fin is to, you can easily see this in any bikes. If it stands, you can see small pieces protruding out of your engines. Now these fins are going to increase the surface area of contact with air. So when your surface area of contact increases, more amount of air can touch these pieces, which is gonna immediately cool your engine down. But we have to be aware that your engines are should be hot. It should not be over hot. It should not be super cold. You have an optimum operating temperatures. So what happens is you have to design your fins in such a way that whenever you design it, it should not be so big like something like this or so small where you're not going to have effective cooling or you're going to have way effective cooling. In both the cases, it is harmful for our engines. So you have to design it in such a way that it does its job of cooling the engine, but not super cooling the engine where you cannot have combustion at all. And it doesn't cool at all where you're going to have overheating of your engines. In case if we overheat our engines, the charge is going to detonate even before we supply with spark. So this is called as a misfiring, and you're going to have pre-ignition of your charge, which is bad for our efficiency. If you use a liquid cooling system, that is, we are going to have a radiator, we are going to have like cooling oils, all those things which are going to be circulated through pumps and stuff inside your tubings, and these are going to run in pipelines around your engines. In that case also, these things are going to provide like a jacket, that is, they'll be running in pipelines around your engines like this. So in a full pipeline around your engines where you can have fluid running, which is going to effectively cool down. So in terms of cooling, when we talk about your cooling, your liquid cooled engines cool your engine way better than whatever air cooled engines can. But why few aircraft uses just your air cooled engines is, if we use our liquid cooled engines, we have to maintain the radiator, we have to maintain the cooling pumps, we have to maintain all the pipelines there, we have to recharge your cooling fluids and all these things. So this is going to be a little costlier than whatever air cooled engines are giving us. So air cooled engines, you literally don't have any maintenance. It's just air that has to touch this fins, and once the fins touch it, it is going to do the better job. So this is one of the reason why our aircrafts were whenever they say always do not do a VX climb, pitch for VY and climb, is because if you do a VX car climb, the airflow into your through your engine car intake is going to be lesser. So it is not going to effectively cool your engine. If we had to always be at that particular attitude, then it is going to overheat our engine, which is going to overstress, and we can have misfiring, which can at the end lead to your engine failure. So that is why we were always asked to pitch for VX, and then after like 50 feet or something, we can pitch down to VY and start our climb when we are clear of the obstacles. The next thing that we'll talk about is your cylinder heads. So your cylinder heads is going to be made up of aluminum. That is the whole part on the top. This is your cylinder ka head. Now your cylinder head is going to be made up of aluminum. Why? Because aluminum dissipates heat way faster than any other metal. So it's not going to retain heat, because at these places only you're going to have combustion happening. So if the some other metal, if you use it, if the heat is being retained, you have springs and all those things which cannot bear that much amount of your heat. So they'll start melting off. To avoid all the smelting, we are going to use aluminum, which is stronger than any other metal. So you're going to have all the seals and stuff. This whole piston cylinder head is going to hold your spark plug. You're going to have camshaft. Remember, we have two types of shaft. One is your crankshaft, that is at the bottom of your engine. We have camshaft, which is at the top. So the job of your camshaft is to tell the engine when to open your valves. Now, how is your camshaft is going to be is, it will be in this shape. It is more or less a teardrop polar shape. So whenever it is like this, it is going to push the spring downwards, which is going to open your valve. When you have it in the opposite way around, like something like this, in that case, it is going to be up and you're going to have the valves closed up. So this helps us in opening and closing of your valves. Now, how are these things going to be connected is these things will be connected via a belt to your crankshaft. So depending upon the rotation of your crank, your camshaft knows when to rotate it. So in if how fast, how much ever faster your camshaft rotates, that is how much faster your camshaft is going to rotate, and that is how much faster you're going to have your valves opening and closing. So this is how you increase your speed of your engine and get more power out of it. So you're going to have all the valve sets, your spark plugs, every single thing that is needed for your engines to be aligned, and we are going to use it. So this is basically your outermost part of your engine, that is your cylinder blocks and your cylinder car heads. The next thing is with that we talked about, that is your valves. So valves ka job is to help us in allowing your inlet and exhaust valves to either put in fuel into your cylinders or take out the exhaust gas out through your out from your cylinders. Now, how are we gonna do it is we are gonna have a camshaft. You can see this more or less a egg-shaped wala thingy. This is your camshaft, which is gonna be connected to your crankshaft. Now this camshaft is going to be spun by the help of a belt from your crankshaft. When it moves up, so when it moves, the pointing head moves, it is going to push this rod. This rod is called as a push rod. That is, it is going to push it. When the push rod pushes this edge up, the other rocker arm is going to push it down. So your valve is going to be forced to open. When your valve opens, it is going to allow fluid to flow. Now, when your crankshaft rotates 180 degrees, this whole camshaft is going to rotate the opposite way, where your push rod falls downwards, which is going to move this part of your push rod to down, rocker arm to down, and your whole thing is going to spring up back. So you're going to have a spring here, which is going to pull up, and it is going to help us in closing our valves. So this is the job of your valves, that is to open, and when you open it you're going to have fuel or either the exhaust air going in or out, and when you close it nothing is going to have. That is going to be your other two strokes. So basically in engineering we used to study how to design this crankshaft, by what degree you have to open it, by what degree you have to close it. So when we talked about your practical auto cycle, we said we are going to lead your opening of your intake valve, we are going to lag your closing of your exhaust valve and all those things. Those all things we have to design using your camshaft, because your crankshaft we can't do much about it, but your camshaft we can alter the like shape of it, where it can open and close either early or later. If we have a wrong camshaft, or your camshaft is bent, or your camshaft is gone blunt, your whole engine is not going to work properly, because your valve is not going to open correctly down or up, which is going to cause us problems with it. So you have to be aware that you have to have a correctly adjusted camshaft, which is going to help us in opening it. Next is your sump. So your sump is the bottommost part of your engine. Now, the first thing that we saw, that is your barrel or your blocks. You can see here we have small lines here, right? So these are the fins that I was talking about. So this is basically our Cessna car engine, where you have your horizontally opposed, and you can see so many lines. Those are your barrel blocks, which helps us in increasing the surface area that is going to be exposed to our airflow, which helps us in cooling our aircraft car engine down. Now you have a sump. So this is called as a wet sump system. Whatever we have in a Cessna is a wet sump system. What do we mean by wet sump system is we are going to have your engine oil straight away poured under into the crankshaft shaft. So your crankshaft is going to hold the sump, where you're going to have all the oil available. Whenever your crankshaft rotate, the rotatory motion is going to spill oil into it, helping in lubricating, cooling, cleaning, and washing away all the dirts from your from your engine car cylinders. So you'll have a oil reserve, that is basically a sump, and it is also going to have a oil filter, which is going to help us in filtering the oil if there is any amount of dirt or debris that is going to be there. The second component way under your engine is your carburetor. So the job of your carburetor, as we already know, is to mix air and fuel together. So that is where you're going to have the right amount of fuel and air mixing, and we can control the amount of fuel entering to our mixer setting. So we can lean it if we are way higher because of decreased in density, and we can reach it when we are low in altitude when we have a increase in density. So Depending upon whether we are climbing up or descending down, we are going to adjust the amount of fuel that is going to be supplied into your carburetor, which basically works on the Bernoulli's principle. That is, we are going to create a low pressure zone by using a venturi, which sucks in fuel from the throttle car nozzle, and it is going to go into your engines. And we already know that our carburetors are prone to icing also. Now, if our aircraft is not equipped with a carburetor, if our aircraft is some other thing, it will have a fuel injector. Your fuel injector will be not kept here. Your fuel injector will supply it straight to the induction manifold. It will be constantly supplying fuel under high pressure into your induction manifold. Until this point, you will have only air coming in. So at this point, you will have a fuel injector which pumps in fuel at high pressure, which is then going to go into your cylinders, and you're going to have effective combustion. So this is your either your carburetor or your fuel injector. Then you have your exhaust system. So your exhaust system is going to help us in carrying out all the exhaust gas from the cylinders into the out to the atmosphere. So it has to do a good job. So you have to have a length like pipe which is not so much bent and all, because if there is any bends and stuff, it is going to increase the pressure of your flow of your airflow, which is going to restrict it. So to not have any restrictions throughout your entire exhaust, it will mostly be made up of straight pipes. Anything that you see, your aircraft, your cars, your bikes, anything, it will mostly be straight pipes, or even if it has slight bends, it will be slight bends only, not 90-degree walla turns and stuff. So that helps us in sending out all the exhaust gas outside. Then you are going to have a accessory housing. So accessory housing is going to have anything, that is, you can have it in the front or in the back of your engine. So this is where your propeller is going to be connected, and this point is mostly your accessory housing, where you can have your electrical hydraulic lines, your generators, your oil pumps, your fuel pumps. If you have a supercharger, you can connect a supercharger, a starter motor, and you also have your magnetos. So you can see your magnetos 1 and 2, that is left and right. You have your starter motor, which is gonna, when you turn on it, by using battery ka power, this is gonna spin your crankshaft. When your crankshaft spins, your piston is gonna move, which is gonna start firing, and when it fires, your magnetos gets that power and it overtakes it. And once you have enough firing that is happening inside the engine, your engine starts and it spins automatically on its own. So these are the whole block of your engine. That is, you have your cylinders, 4 cylinders horizontally opposed. You have your crankshaft, you have your propellers which will be connected here, you have your intake manifold, you have carburetor, sump, generator, and magnetos, which is going to help us in giving our spark plug the required spark amount. And then you will have a gearbox. So the job of your gearbox is, in some cases, like in when we talk about your turboprop engines and all, like ATRs and stuff, the amount of engine power produced by that particular engine is super high. The propeller will spin super fast. That is, the tip of the propeller can bypass the speed of sound. That is, it will go supersonic. To not let this happen, even though our engine is spinning at a very high power to produce that much amount of power, to not let this propeller also spin at the same way, we can slow down the rotation of your propeller by using gears. It is basically, you are going to use planetary gear or spur gear. So spur gear is whatever we have it in our cycle ka chain. That is technically not a spur gear. I'll show an image of a spur gear which is going to help you. But when we talk about that, I'll show you how a spur gear is going to work and how your planetary gears are going to work. You have different types of gear mechanism, which helps us in slowing your propeller down. Even though your engine spins faster, your propeller is not going to spin that high faster, because at the end, when your engine is spinning faster, if your propeller spins at the same speed, the tips of your propeller will hit supersonic speed, which is going to lose its effectiveness in producing a lift, because our propellers are basically aerofoil shapes. It is an aerofoil. It is basically a wing that produces thrust, right? If it hits supersonic, we are not going to have lift that is being produced by your propellers, which means we don't have thrust to propel us forward. So it is basically of no use. So that is your gearbox ka job. Then we are going to have engine classifications. That is, your engines are going to be classified in all these different forms. First is, we are going to talk about your cylinder arrangement. So cylinder arrangement is, it is going to talk about are we having a V-type engine, or is it an inline engine? Is it a W-type engine? Is it a radial engine? Is it a horizontally opposed engine? What is the engine ka arrangement? Oh, sorry, cylinder ka arrangement. Second one is what is the type of drive? That is, is it connected to some sort of like a mechanism, like gear mechanism or something, or is it directly driven? So our aircrafts are directly driven. That is, you have a crankshaft connected straight to your propeller. That's it, done. If we talk about your bikes and stuff, our bikes use either a belt drive or a chain drive. Bikes and all will have chains at the back. So the chain goes from your engine crankshaft to the back of the wheel, and your wheel starts spinning. This is called as a chain drive. This is called as a direct drive, and in some cases you have belts also, that is called as a belt drive. Then your rotation of direction, that is, which way does our engine spin? Is it like anti-clockwise rotation or is it clockwise rotation? That is going to be given. Then your cylinder capacity. So and two-wheelers and all, it will be given in cubic centimeters. In aircraft, it will be given in cubic inches. How much cubic inches of capacity does each cylinder have? Then we have cooling method. So we are going to talk about is it a like air cooled system or a liquid cooled system? How is it going to work? Type of fuel used, 100 ll, 100, is it jet A, jet B, all this type of fuel. And we'll talk about lastly about your normally aspirated or supercharged. Normally aspirated is it breathing normally? This part, that particular part you see at the back of this engine, is called as a turbocharger. So we'll explain this later when we come to that particular chapter, what is a turbocharger. But in short, if I have to explain it, it uses a exhaust gas to spin a turbine, which is going to spin a intake valve, which is going to compress some amount of gas already. This compressed gas is going to then be flown into your intake manifold and then goes into your engine. So what advantage it gives us over your normally aspirated engines is, if we go in high altitudes, at very high altitudes, we have decrease in density. So that density is sufficiently not enough for our engines to keep on firing, because when we go up and up, we start leaning the mixture more and more and more. So at high altitudes, when you have taken out all the mixture ka setting, your aircraft cannot produce any more power. But what we can do is we can use this turbocharger to help us in increasing the compression ratio. That is, even though let's imagine that we are flying at 10,000 feet, by using turbocharger, you'll have air density of whatever you can get at 5,000 feet. So when you go to 15,000 only, you'll have a charge cut density as whatever you'll get at 10,000 feet. So this gives us another 5,000 to 10,000 feet of added advantage. So that is why we use a turbocharged engine. So when you talk about a turbocharged, we'll have a turbocharger, or we also have a supercharger. So we have two different things, a supercharger and a turbocharger. So your engine will always be written as this, which we already know in our Cessna PH also. You'll have this L2C 320 something, I forgot what exactly it is. So this is gonna talk about it. So AE stands for aerobatic. That is, your aircraft has an aerobatic engines. Then your I is injected fuel system. That is, since it's an aerobatic engine, we are not going to have gravity fed system, because if you go inverted, your gravity will not help in sending fuel into your engine. It is gonna be in the opposite way. So if you have to do aerobatic maneuvers, your aircraft has to be fuel injected, then only you can do it. Then you have your O stands for your horizontally opposed, and 540 is the displacement in cubic inches. So this particular engine is 540 cubic inches of displacement. Then L is your left hand rotation, and IB5 is specific modifications that is being done. And you have your S and GS, your gears and supercharged if it's included. So you'll have either these two. It's not there, so it's not neither geared nor supercharged. It is just these three things that are going to be given for this particular type of engines. So with this, we are done with the introduction of your piston engine. So do you have any doubts in the name of your engine car types? What is the name of each barrel, blocks? Any doubts in that?
नहीं अभी तक नहीं.
Okay. So I'll send you this PDF, I mean PPT. You can go through it. If you have any doubts, let me know. I'll explain it again. Okay. So these things are very easy because you already flew it. You already know half of it, I guess. Few things alone will have to do it. That's it.
Okay. Can you share me yesterday's PPT
Yeah,
as
yeah.
well?
I just attached these two things. Yesterday it was incomplete basically, so I didn't send you. Now
अच्छा अच्छा ठीक है.
I'll send you in like 20 minutes.
आराम से you can send.
Okay. Done. So I'll see you tomorrow.
Yeah.
Okay. Bye bye.
Bye. Good night.